major cosmic Earth impact event occurred about 12,800 years ago. Now there's geologic evidence to support this theory. This is the Clovis Comet, and what we call the younger DRYAS Comet. And we know Graham Hancock has given us a lot of information about this. We have a map by Mario Pino showing 53 younger DRYAS sites. Orange dots represent 28 sites with peaks in both platinum and other impact proxies, such as high temperature iron-rich spherules, and the red dots represent 24 sites with impact proxies but lacking PT measurements. So the map shows 53 younger DRYAS sites, and they're all over the world. Mostly, they first found them in North America, then they found them in Europe, then they found them as well in South America and even Australia, which is not here on the map. So the younger DRYAS, according to Wikipedia, as we know, the Clovis Comet also, because that was the end of the Clovis culture in North America. Large fragments of more than 4 kilometers in diameter, you can imagine how huge they were, disintegrated asteroid or comet struck North America, South America, Europe, Western Asia, and even Australia 12,800 years ago, with multiple meteor airbursts and impacts, produced the younger DRYAS boundary layer, depositing peak concentrations of platinum, high temperature spherules, metal, glass, and nanodiamonds, forming an isochronous datum at more than 50 sites across the Earth. Some scientists have proposed that this event triggered extensive biomass burning, a brief impact winter, and the younger DRYAS abrupt climate change contributed to extinctions of late Pleistocene megafauna, such as the woolly mammoth and other animals, and of course the Clovis culture in North America. Finally, support my Patreon account. The daily posts are 5 videos daily, and they are totally different from what I have on my YouTube channel. Thank you so much for your support and that you find all my content so interesting. You'll find the Patreon account details in the description box. And there are those that believe that this is what also caused the deluge. But going to the article, this is by Sonia Fernandez, University of California, research at Santa Barbara. When UC Santa Barbara geology professor emeritus James Kennett and colleagues set out years ago to examine signs of a major cosmic impact that occurred towards the end of the Pleistocene epoch, little did they know just how far-reaching the projected climate effect would be. They said, "It's much more extreme than I ever thought when I started this work," Kenneth said. "The more work that has been done, the more extreme it seems." He's talking about the younger DRYAS impact hypothesis, which postulates that a fragmented comet slammed into Earth close to 12,800 years ago, causing rapid climatic changes, megafaunal extinctions, sudden human population decreases, and cultural shifts and widespread wildfires, biomass burning. The hypothesis suggested a possible triggering mechanism for the abrupt changes in climate at the time, so it was a worldwide effect, you see. In particular, a rapid cooling in the northern hemisphere called the younger DRYAS amid a general global trend of natural warming and ice sheet melting evidenced by changes in the fossil and sediment record. Controversial from the time it was proposed, the hypothesis even now continues to be contested by those who prefer to attribute the end Pleistocene reversal in warming entirely to terrestrial causes. But Kennett and fellow stalwarts of the younger DRYAS boundary, YDB for short, the Earth impact hypothesis, as it's also known, with these huge pieces of 4 kilometers each, have recently received a major boost. The discovery of a very young 31-kilometer wide impact crater beneath the Greenland ice sheet, which they believe may have been one of the many comet fragments that impacted Earth on the onset of the younger DRYAS. And now in a paper published in the journal Scientific Reports, Kennett and colleagues led by Chilean paleontologist Mario Pino present further evidence of a cosmic impact, that is, a cosmic body impacting our Earth, this time far south of the equator, that likely led to biomass burning, climate change, and megafaunal extinctions nearly 13,000 years ago. Kenneth said, "We have identified the younger Dryas boundary layer at high latitudes in the southern hemisphere at near 41 degrees south, close to the tip of South America," Kenneth said. This is a major expansion of the extent of the younger Dryas boundary event. The vast majority of evidence to date, he said, has been found in the northern hemisphere. Well, they also found it in the southern hemisphere, and it was all over the place. Okay, that's new evidence. Now, this discovery began several years ago, according to Kenneth, when a group of Chilean scientists studied sediment layers at a well-known quaternary paleontological and archaeological site in Pilauco, Bajo. It's basically towards the tip of South America, as we see on the map, and recognized changes known to be associated with the younger Dryas boundary impact event. They included a black mat layer, 12,800 years in age, that coincided with the disappearance of South America Pleistocene megafauna fossils, an abrupt shift in regional vegetation, and, of course, a disappearance of human artifacts. That means humans also went extinct in that area. Now, because the sequencing of these events looked like what had already been described in the younger Dryas papers for North America and Western Europe, the group decided to run analysis of impact-related proxies in search of the younger Dryas layer, Kenneth said. This yielded the presence of microscopic spherules interpreted to have been formed by melting due to the extremely high temperatures associated with impact. The layer containing these spherules also show peak concentrations of platinum and gold and native iron particles rarely found in nature. Among the most important spherules are those that are chromium-rich, Kenneth said. The Pilauco site spherules of South America contain an unusual level of chromium, an element not found in Northern Hemisphere younger Dryas impact spherules, but in South America. It turns out that volcanic rocks in the southern Andes can be rich in chromium, and these rocks provided a local source for this chromium, he said. Thus, the cometary objects must have hit South America as well. Other evidence, which Kenneth noted, is consistent with previous and ongoing documentation of the region by Chilean scientists, pointed to the very large environmental disruption at about 40 degrees south. These include a large biomass burning event, evidenced by, among other things, micro-charcoal and signs of burning in pollen samples collected at the impact site. It's by far the biggest burn event in the region we see in the record that spans thousands of years, Kenneth said. Furthermore, he said, the burning coincides with the timing of major younger Dryas boundary-related burning events in North America and Western Europe. The sedimentary layers at Pilauco contain a valuable record of pollen and seeds that show change in character of regional vegetation, evidence of a shifting climate. However, in contrast to the Northern Hemisphere, where conditions became colder and wetter at the onset of the younger Dryas, the opposite occurred in the Southern Hemisphere. The plant assemblages indicate that there was an abrupt and major shift in the vegetation from wet, cold conditions at Pilauco to warm, dry conditions, Kenneth said. And according to him, the atmospheric zonal climatic belts shifted like a seesaw, with a synergistic mechanism bringing warming to the southern hemisphere, even as the northern hemisphere experienced cooling and expanded sea ice. The rapidity within a few years with which the climate shifted is best attributed to impact-related shifts in atmospheric systems rather than to the slower oceanic processes, Kenneth said. Meanwhile, the impact with its associated major environmental effects, including burning, is thought to have contributed to the extinction of local South American Pleistocene megafauna, including giant ground sloths, saber-toothed cats, mammoths, and elephant-like Gomphotheris, as well as the termination of the culture similar to the Clovis culture in the north, he said. The amounts of bones, artifacts, and megafauna-associated fungi that were relatively abundant in the soil at the Pilauco site declined precipitously at the impact layer, indicating a major local disruption. The distance of this recently identified younger Dryas boundary site, about 6,000 kilometers from the closest well-studied site in South America, and its correlation with the many northern hemispheric sites, greatly expands the extent of the younger Dryas boundary impact event, Kenneth said. The sedimentary and paleovegetation evidence gathered at the Pilauco site is in line with previous separate studies conducted by Chilean scientists that indicate a widespread burn and sudden major climate shifts in the region at about younger Dryas boundary onset. This new study further bolsters the hypothesis that a cosmic impact triggered the atmospheric and oceanic conditions of the younger Dryas, he said. This is further evidence that the younger Dryas climactic onset is an extreme global event with major consequences on the animal life and human life at the time, Kenneth said. And this Pilauco section is consistent with that. So this younger Dryas destruction, this comet impact, the Earth impact destruction took place all the way down from the northern hemisphere, from the area of what we see, even Greenland was hit, all the way down to the tip of South America. You can imagine the extinction level event that went on. This is on phys.org by University of California, Santa Barbara, and Wikipedia. Please leave your comments. Thank you for your support.